Hi students, I am going to teach you a very important technique in finding circumcenter, orthocenter, incenter whenever a triangle is given. That I am going to teach you. So listen everybody. Now I am going to take a triangle ABC. So this is a triangle ABC. There are three vertices, of course. There are three vertices. If the three vertices are given, then how can you find out all these three? Whenever three vertices are given, first we have to find out AB distance and BC distance and CA distance. That means you can find out the distance using the distance formula. Of course, you are well known. So after getting the distance AB, BC, CA, what is the formula? Whenever if you know the 2 points, how to find out the distance between the 2 points? Under root of x2 minus x1 whole square plus y2 minus y1 whole square, that is under root. So after getting AB value, BC value, CA, that means we got the length of the three sides. I think you are following. So after getting the three lengths, the length of the three sides, okay. Now if you get AB equal to BC equal to CA, that means what you say? The triangle is going to be equilateral triangle. If all the three sides lengths are equal, we can say that is what here? A right angle triangle. So if it is a right angle triangle, then what about circumcenter? What about orthocenter? And what about incenter? So no need to find out separately how to find out circumcenter, orthocenter, incenter. There is a technique. That is nothing but if the triangle is equilateral triangle, the triangle is what here? Equilateral triangle. If the triangle is equilateral triangle, now that is G. What is G here? The centroid. Centroid itself is going to be what here? Circumcenter and orthocenter and incenter. What is the formula to find out the centroid? If you know the three vertices, that is x1 comma y1 and x2 comma y2 and x3 comma y3. So the centroid formula already you are well known, that is nothing but x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. So this is the centroid formula, children. So whenever you got the equilateral triangle, the centroid itself is what? Circumcenter. I am going to represent circumcenter with the letter what here? S. And orthocenter H and incenter is I. So no need to find out SHI separately. So this is here the technique is what? Equilateral triangle is there. Then you have to find out only the centroid. That itself is what? Circumcenter and orthocenter and incenter. This is the technique. Whenever the triangle is what here? Equilateral triangle. Sometimes the triangle is not going to be equilateral triangle. So this is the first point. If at all equilateral triangle, the centroid itself is what? Circumcenter, orthocenter and incenter. So that is simply we can find out by only G. Now coming to the second point. If the triangle is a right angle triangle, suppose after getting AB, BC, CA, sometimes if you get the equation like this, AB whole square and plus BC whole square is equal to CA whole square. If you get like this, for example, depending upon the values of AB, BC, CA, you will get like this, for example. Then children, you can observe here, what is the common point here? So what is this indicates? This indicates that nothing but satisfying what here? Pythagoras theorem. So Pythagoras theorem. So that is AB square plus BC square equal to CA square. If this condition follows, so here see the point B is there na, that B point itself is said to be what here? Orthocenter. The point is what here? Orthocenter. The capital B, whatever the vertex B here, that is going to be the orthocenter of the triangle ABC. I think you got my point. If this is condition satisfies, the common point B is there na, that B vertex itself is the orthocenter. Now coming to the circumcenter, this is going to be what here? Hypotenuse, because this is CA is hypotenuse. So midpoint of CA, midpoint of CA. So midpoint of CA is going to be what here? Circumcenter. I think you are following. how to find out the circumcenter and how to find out the orthocenter if the triangle is going to be what here? Right angle triangle. What do you call this one? This is nothing but right angle triangle. Right angle triangle. Right angle triangle we can say. Right angle triangle. So this is the very important formula to find out the orthocenter and to find out the circumcenter. Midpoint of CA nothing but already you are well known. Midpoint of any 2 points are x1 plus x2 by 2 comma y1 plus y2 by 2. Right. So this is the second technique to find out the orthocenter and circumcenter whenever the right angle triangle. Whereas we discussed there in the previous one, if a triangle is equilateral triangle, then we can say the centroid itself is going to be orthocenter and incenter and circumcenter. I think you got my point. So this is a very important technique to find out the circumcenter and orthocenter and incenter. I think you got it, my point. So thank you.